We'll be doing our last two exponent rules today here, the division properties of exponents. This is chapter 7, day 4. So the last two we need to look at are the ones that are about dividing, the quotient rule. So the first one is, we know that when you multiply like bases, you add the exponents. When you divide like bases, you subtract the exponents. So when you divide like bases, you subtract the exponents. The last one is, if you have a division, a fraction, and it's to a power, that power goes to the numerator and to the denominator. It's called power of a quotient. Right? So when you have a power on the outside of a fraction, it goes to the numerator and the denominator, both top and bottom. And when you divide like bases, you subtract the exponents. So like number 1 here, we've got a 4 to the first and a 4 to the first. So that'd be like 4 to the 1 minus 1. And then n to the 3 minus 1, right? So I really wouldn't write that out in the long run. So 1 minus 1 would be 0. 3 minus 1 would be 2. Power of 0 is nothing, so we're just left with n squared. Right? Same thing on the next one. We have 4 over 4, so 4 to the 1 minus 1 is 0. X to the 4 minus 0 is 4, which you would have gotten the same thing if you just crossed out that x to the 0. 4 to the 0 is gone, so we're just at x to the 4. So we have k on top and bottom, so 3 minus negative 2 would be k to the 5th. 2 is still in the denominator. Nothing wrong with that. That is done. We have v's on top, v's on bottom, so we have the 4. And then v to the, it's always top minus bottom, and the answer goes on top. So 4 minus negative 3 is 7. And then 4v to the 7th would be done. So you combine it with all the other properties also. A couple ways you can go about this one. I'm going to, like we've done before, power of zeros are gone, so we can cancel those out. So I just have 3x to the 4th y squared on the bottom, which means I'd have to put the 1 on top. All right, here I can see I have the 3 over 3, which is going to cancel, right? Because 3 to the 1 minus 1 is 0, that's gone. I have n to the negative 1. N to the 4 minus 3 would be 1. To get rid of a negative exponent, I would move it. But if n to the first we don't write, over m to the first we don't write. So n over m. So 7, I have 2 on top, 3 on bottom. Just like a normal fraction, I cannot simplify that. I've got u to the 1 minus negative 1 would be 2. V to the negative 4 minus negative 2 would be negative 2. Well, I have to move my negative exponent. So I have the 2u squared on top. It'd be 3v squared on the bottom in the denominator. Let's see, here I have 3 over 2. Again, I can't simplify 3 over 2. I've got x's on top and bottom, so x to the 1 minus 4 is negative 3. Y to the 3 minus 4 is negative 1. So then I would move my negative exponents. So 3 gets to stay on top. I have 2x to the positive 3 on bottom, y to the positive 1 on bottom. So we're now having to think about all the different properties. Number 9, I'm going to simplify if I can inside the parentheses. So let's see, power of 0 is gone. So I've got 2a on top. On the bottom, 2 times 2 is 4. When I multiply like bases, I add the exponents. So 3 plus negative 4 is negative 1. This is all still to the power of negative 2. Well, 2 over 4 would be 1 over 2, right? 2/4 is 1/2. And then I have a's on top and a's on bottom. So a to the 1 minus negative 1 is 2. Still to the power of negative 2. So now I bring that negative 2 to the top and to the bottom. And if there's a power already there, I multiply. So a to the 2 times negative 2 is negative 4. 2 to the negative 2. So now they're both negative. I'm going to have to move the a's to the bottom, the 2's to the top. So I have 2 squared on top, a to the 4th on bottom. And then the last thing, 2 squared would be 4 over a to the 4th. And that's just one way to go through that problem. As long as you follow the properties, there are different ways you could go through. Number 10, I'm going to simplify this numerator first. So let's see, I've got 2 p to the, when you multiply like bases, you add the exponents. -1 plus -1 is -2 over 2p squared, still to the power of -2. 2 over 2 would cancel. So let's see, when I divide like bases, I subtract the exponent. So -2 minus 2 is -4, still to the power of -2. When I have a power of a power, I multiply. So p to the -4 times -2 is 8. So I end up at p to the power of 8. Let's see what we've got going on in 11. I'm going to simplify this multiplication inside the parentheses first. So I have 2m to the 0, because when I multiply like bases, I add the exponents, right? So 4 plus -4 is 0, still the power of -4. Well, m to the 0 is nothing, so this is really 2 to the -4 over m cubed would be m to the 9. So then to get rid of my negative exponent, I make it positive and move it to the denominator. So I have 2 to the 4th, m to the 9th. So I need a 1 on top. So then 2 to the 4th, 2, 4, 8 is 16. So I have 1 over 16, m to the 9th. All right, last one here. Inside the parentheses, there's nothing I can do. So I'm going to bring in that -3. So I have x to the -3 times 2 to the -3. X to the 2 times -3 is -6. I'm going to go ahead and multiply that together. So I have 2 to the -3. X to the, when you multiply like bases, you add the exponents. So -3 plus -6 is -9 over 2x to the -4. So I see I have bases of 2. So when you divide like bases, you subtract the exponents. So -3 minus 1 would be -4. So 2 to the -4. X to the -9 minus -4 is -5. So then I'm going to have to move my negative exponents. So I have 2 to the +4 on bottom, x to the +5 on bottom. So 1 on top. So then I'm at 1 over 2 to the 4th is 16, x to the 5th. So those are all of the properties together now. You can review them on the front cover, the back page of the front cover. There's a list of all the properties for your use.